Okay, we are about going live. All right, we are live. Let me even send you the link on WhatsApp. Okay. I sent you. Let me now make you host.
Okay.
Let me make you host now. Okay, you have co-host. Okay.
Okay, there's host.
Let me. All right, you are now co-host. Once it's fine, I will now send it. Yes, I can see introduction to internet. Wait, let me check on YouTube whether it's showing there. No, they have a little delay on YouTube. Yes, your own is showing on YouTube. So it's fine now. I sent you the YouTube link. So you can always, when you ask questions, you give those on YouTube a little bit time. They will respond. All right. So let me be inviting them. Make sure you are connected. Once they are 300, the rest will be going on YouTube to connect. So I will share the YouTube link and also the.
So the recording.
Okay, yeah, I've not started. Let me put the record. Once I record, we have to stop chatting so that people will not hear what we are saying. So I'm putting it on recording now to iCloud.
Okay.
Yeah. All right, logs and invite them.
Morning, everybody. You're welcome to FSC 113 class. So I will just wait a bit for some other people to join us before I start the class. So I wait for like 5 more minutes and I will start the class. Thank you. All right, good morning. Welcome to the last class of FSC 113 for this semester. I'm sure you guys have learned a lot from chapter 1 down to 4, down to 5. And this morning I'll be taking the last chapter of the textbook, which is Internet, Introduction to Internet, because we can't cover everything about the Internet in just a class and in just the scope of this course. So all you'll be hearing this morning are just a few points about the Internet, just for you to get an introduction. Since this course is Introduction to Computer Science, so you're going to be getting just introduction to the Internet, just to have a general overview of what happens on the Internet, what is the Internet, the history of the Internet, how do we get here using the Internet, how do we, where did this start from, what is an Internet, and what are the services provided on the Internet, and how does communication occurs, file transfers and all that are done on the Internet. So this morning I'm going to start with this definition. This slide is prepared for this lecture, where I try to look at different things that is being said, and basically some of my pictures are taken from the Internet Society, the World Internet Society. I took some of my pictures from them, so I'm referencing them. So what is the Internet? The network of networks. So that brings us to say, what is a network? So a network is connection of two or more computers. When we have two or more computers connected together for the purpose of communication. I have a laptop, another laptop, maybe two, starting from two or more, connected together. Either they are together in a particular location or they are not in a particular location. They are not on the same location. That's a network. So when we now say Internet is a network of networks, that means that I have a network somewhere joining that consists of two or more computers together. And I have some other networks, some other places, and they are all connected together. So Internet is a network of networks joining many governments, universities, private computers, and providing infrastructure for the use of email, bulletin boards, file archives, hypertext documents, databases, and all computational resources. So all of that things can be done on the internet apart from emails and the file archiving and hypertext documents and all that. So, but they are all for communication. So it depends on the kind of communication you want to do. So another definition for the internet is a vast collection of computer networks which form and act as a single huge network. So an internet is collection of different networks, but you can also call an internet one huge network, which has networks under, for transport of data and messages across distances, which can be anywhere from the same office, like I said, to anywhere in the world and all that. So, in short, I said an internet is the largest network of networks in the world. Now, it uses TCP/IP protocols and packet switching. I'm going to be talking on that, more on that later before I end this lecture. And it runs on any communication substrate. So the communication doesn't just work on some communication substrates. So on the internet, there are protocols for file transfer, for message transfer, there are protocols. So I'm going to be talking more on that. So now I want us to see where the internet is coming from, where the internet starts. Where the internet starts. And we discover that this started around the 1960s. In the 1960s, most universities and government agencies had individual mainframe computers, and there were no communication. Okay, so everybody, all the mainframe computers were working independently, no communications on them. But in 1969, the US Department of Defense Advanced Research Project Agency created, based on their research, this department is, all they do is research, and they have to research how can they make one or two computers talk to each other. So they were able to come up with a project, and they created an experimental network called the ARPANET. So the ARPANET is more or less the first internet. So it's a test bed, like a foundation for emerging network technologies. So originally, the ARPANET connected just four universities. That means a mainframe computer in one university, the other university, and the other universities. So the ARPANET connected 4 universities together and enabled scientists to share info and resources across long distances. I said what was in use that time were mainframe computers. And the size of a mainframe computer, very big computer, but like the size of a whole room. So that was where the network began. So the ARPANET continued to expand in the 70s and 80s. Continued to expand, and then the functionalities continued to expand in the 70s. So in 1972, National Center for Supercomputing developed Telnet application for remote login, making it easier to connect to a remote computer. In 1973, there was a protocol that was created called File Transfer Protocol. It was introduced. So meaning that the transfer of files between network computers were standardized. That means that if you are not using that particular protocol, in between, if a computer system is not following that particular protocol, it's not going to be able to transfer files to other protocols. So I'm going to talk more on that later. So 1980s, 1983 precisely, TCP/IP protocols became the only set of protocols used on ARPANET. This sets a standard for all networks and generate the use of the term internet as a network of networks. So after that, internet splitted into 2 networks. I said the people that invented the ARPANET were military. They were the military, Department of Defense research in the US. So later they had to split the ARPANET into 2. Because of security reasons, into 2. So we now 2 separate networks. We have now had, so they have the ARPANET and the MailNet. So in between, after that, between 85 to 86, National Science Foundation, NSF, connect the US supercomputer centers together, calling it NSFNet. You know, the reason why NSFNet was designed was to primarily design to link supercomputers so that universities could exchange research information and computing power. So because of this invention, the capability of this net, this NSFNet, it has a very high speed. One of the improvements that brought about the NSFNet is the high speed of information transfer. So they're able to work on the speed of ARPANET. We were able to improve on the speed. So this made, the NSF to become a new backbone of the internet, a new foundation. It's like they created a new foundation. So, and they also developed the regional nets, which were then connected to the NSF. So now, this brought us to the 1990s, where the ARPANET was totally dissolved. And we had new, because it looks as if the foundation was, since the NSF had been created, to make that was a new standard for networking. So ARPANET was dissolved in 1990, and the GOVA was developed to replace ARPANET. So when we say that, we mean that ARPANET is just a structure. Okay? It's a net. It's a structure. So a new structure was put in place called GOVA for networking. So, and this provides an hierarchical menu-based method for providing and allocating information on the internet. So all this didn't start, all the resources we have on the internet now, to click on this and click on it and use this browser and all that, and accept cookies, downloads and all that, didn't start in a day. They were based on inventions from one level to another. So in 1993, WWW, World Wide Web, was developed by Tim Berners-Lee. So there was nothing like WWW, there wasn't like the World Wide Web before. It was a new invention in 1993, and it was released by SED. It's a corporation. So now, from this 1993, we had things like HTTP, Hypertext Transfer Protocol, and Hypertext, revolutionizing the way information is presented and accessed on the internet. So we have the web design, I see a website and all that. And the Hypertext markup language is HTML, used to develop the language that is developed to design a web. So that takes us to after 93 to 95. We see some also improvements, version of web browsers and all that. So in 1995, we have NSFNet. We talked about that before. National Science Foundation, a network that was like a backbone after the ARPANET, was replaced by a new architecture which utilizes regional networks and network access points. So in 1980s, we had okay. Sorry, I think I was supposed to talk about this in 1980s. Right, so I skipped this slide. It was supposed to be after 1970s, where we have the first desktop computer. You know, in 1970s and 1960s, we talked about use of mainframe computers, supercomputing. Then we had the first desktop computer in 1980s, which allowed the communication and network nodes. When I mean nodes, I mean the computers that are connected on the internet, allow the network nodes to be easier. So I think I skipped that before. All right, so this brought us to 1995, where NSFNet is replaced by a new architecture called the VBNS, which utilizes regional networks and access points. So let's see a brief summary of all I've been saying for some time now. Let's look at this picture. You will see from 1968 to 1966. You see that around 1968 to 69, we had ARPANET, we had TCP/IP. TCP is transmission control protocols / internet protocols. So when transmissions are done on the internet, they follow some sort of protocols. You know, it was invented around 1969 to 1970. And we have the first gateway in 1980. ARPANET was widely used. Around 1982, ARPANET transitioned to TCP/IP. Around 1984, ARPANET was split to two, MuleNet and ARPANET. In 1986, NSI was initiated. See, when you look at the internet, when you look at different textbooks and all that, you see different people talking about different histories, but you see a relation in a way about the history of internet. So this picture is from the Internet Society. So in 1970, you see that we had, apart from, because of the enlargements of the functionality of the internet, high speed, network access points, and that. So as all those things were increasing, protocols were also introduced. More protocols were introduced. So we have multi-protocol environment. And if you look at the last part of this, the down part of this diagram, you see operational networks on internet. First, we have 3 networks. Later, it gives like 20 networks, 60 networks. So around 1996, we had like 50,000 networks on the internet. So this is another diagram to explain to you what happened all this while. So initially, you can only access computers, store information on the computer system around that 1994, maybe on the mainframe computer, just store the information. Later, we had the development of sending and receiving data. Later, we had the development of using bits. Bits. You can only send data converted to bits. Send and receive data using bits. Later, there was the development of digital circuits. Aged on the silicon instead of bits. Now, later, we had the around 1950, there was an accomplishment of vast network of computer to use for accessing information and sharing ideas. Now, 19 After that, we had packet switching. Now, I've not talked about packets and then the TCP/IP properly. I'm going to talk about that. So later, we had hypertext can be used to allow rapid access to text data. Then there was an improvement on packet switching over a WAN. That's a wide area network. So next, we have from 1970s, 1995. So you see that, initially they were using, this was the idea of 1940s to 1969, that was the structure that was on ground, they were being used. So this was later moved to accepting the use of protocols and packets, over our networks. So later, ARPANET needs to convert the standard protocol and be renamed to the internet. Now, all right, I think I'm going to get to that. ARPANET was renamed to internet because that was around 1980. So nobody was saying ARPANET again, though it's a foundation, but it's now internet. So later we see up the years, computer connected via the internet can be used more easily if hypertext links are enabled using HTMLs and URLs. That means on a computer system, I have my browser. And on the browser there are links. On the web page there are links that once I click, it can link me to other websites and all that. And this was made possible by the use of HTML. So later we had the World Wide Web, which is easier to use if you have a browser to access the web pages running in graphical user context. So great efficiencies can be accomplished if we use the internet and the World Wide Web around 1995. So this brings us to internet growth trends. So how many hosts can we have on the internet? How many hosts? Host just means a personal computer or a phone that can browse. So can have different hosts. So it's just an individual access. Host means an individual access, a personal access, maybe a personal computer or a tab or a phone, a device that can connect to the internet. So you can see from 1977 to down, from more than 11 hosts to around 213 hosts, 562 hosts, 1,000 hosts, till 1 million hosts. In 2001, we had 150 to 105 million hosts. 2002, we had 200 million hosts. 2010, about 80% of the planet can be on the internet accessing a particular site at the same time. So you can see the improvement that brought us to today. Okay, so I said the other time that I have not talked about protocols. So I want us to look at internet networking protocols. So communications on the internet is controlled by a set of two protocols, which is the TCP/IP. And I said the TCP is transmission control protocols and internet protocols. Every new network that joins the internet must designate at least one computer. Now, if there are, we said internet is network of networks. So if a network which consists of two or more computers or two or more hosts is trying to connect to another network, there must be at least one computer in that network that can recognize the protocol of where is sending data or receiving data from. So if you work in the networking environment, you understand how all this issue works. Say, talking about IP address, And that's the internet protocol address and all that. What's the IP address of that place? What's this and other? So those are the things we use to access a particular place on the internet, particular point on the internet. So we said that if one or more computer system, please off your, if your video is on, please off it. Your camera is on, please off your camera. So we said every network on the node must follow the protocol on the internet. So TCP/IP is called Transmission Control Protocol, and IP, Internet Protocol. So a network protocol is used by all computers and network on the internet. So everybody should please check your video, your camera, and be sure I can see some students, some videos on. Check your video and put it off, because that's going to be eating up many people's data. So please do that. Olufemi Adebo, I can see your video on. So, and it was originally developed by the US Department of Defense for Unix, but it's now available on every OS, every operating system. So how does this work? The Transmission Control Protocol, TCP, breaks down every message you send on the internet into packets. It breaks them down into packets. So, and when they are broken down into packets, and packets are called data chunks, chunks of data chunks. They're called data chunks. So the TCP breaks any message that is being transmitted on the internet into data chunks called packets. And then the TCP/IP identifies each packet with its own electronic label and mailing address. So each packet has its own mailing address and its own labels. So the individual packets are routed through the network from one computer to another. They are routed through the network. They are routed to the network from one computer to another computer and are reassembled at their destinations. So, what does the IP do? The IP routes the packets. The TCP breaks the message into packets, and the IP, Internet Protocol, routes the packets through the internet to get them to their destination. So when they get to their destination, please off your data. Shola Shojinu, off your video. Off your video. Shola Shojinu, off your video. So when the packet gets to their destination, the IP actually does that, takes them to their destination. Then the packets are, when they reach their destination computer, the destination node, the TCP reassembles them into the original message. So we don't even know what is happening when your data moves, you send a message somewhere, you don't know what is happening to the message. You don't need to know that. We don't need to know that. But what actually happens is that the message is being transmitted into data chunks, and then when they get to where they are going to, they are assembled back by the TCP. So the TCP IP works together. Please, Shola Shojinu, off your data, off your camera. So that's why we have that the TCP IP works together. They always work together. When you see them mentioned, they always mentioned together. Okay, so now we'll go to the next thing now. Last thing we're going to look at is internet services. Internet services. We have different services on the internet, and if you look at your textbook, you will see more on web browsers. The website was a website, and the features of the website and all that. So just try to look up on that. That's just few lines. So I'm going to talk about internet services right now. And any other thing you see that I didn't mention in this lecture, on this slide and in this lecture, take time to look at it in your textbook. There are just few things you can just read up. A few things you can read up. So internet services, we have different services on the internet. These are just some of them. These are some of them. These are not all. Emails, blogging, chatting, social network sites, video conferencing, news group, e-commerce. So we are all familiar with emails. That is rapid and productive means of communication. It's faster than the paper mail, unlike the telephone, which is, that was where we started the communication from and all that. If I call you on phone, it's not everything I can say on phone documented. So in the email, electronic mail is, is an improvement on communication. It's improved for communication. So if and the legalized communication now is legalized now. An email is legalized. If I send you an email, that is a legal, it can be said to be a legal document against you that you have received it, I've sent you, and you have acknowledged it, and it's legalized. Email documents can be stored in a computer and be easily edited using editing software. So now, another thing we have is a blog. And the term blog is an abbreviation of web log. A weblog. It is used to describe a website usually maintained by an individual. A blog is a website usually maintained by an individual. It's a weblog. So you call it blog, but it's actually a weblog. So a blog features remarks, comments, description of events, and all that. So you say, okay, we have different bloggers now. On the internet, we have different bloggers now, and we're not even sure which one is authentic and which one is fake. So, and that has brought us to different researches on fake news identification and all that. So all these things are done on the internet, and there are services provided on the internet, and we even see people trying to bring disinformation and doing illegal and incorrect services on the internet using these blogs. So a blog features remarks, comments, description of events, etc. Entries are usually displayed in the reverse chronological order. It allows us to interact with readers interested in the same topic. So, and we even have this blog creating employment opportunities. So we have some people, when you ask them what they do, they say they are bloggers. And some people they have found their profession in this. They found their, their job in this, and they are making a lot of things out of it. So chatting on the internet, like this, our Zoom now, we know Zoom also provides chatting. Facebook chats, a lot of chat, Twitter, and all that. So internet provides the ability to exchange typed in messages online with people all over the world. It's done through chat rooms or instant messages. A chat room is a virtual room where a real-time online conversation takes place between many computer users. Internet messaging, or IM, is a real-time online communication with a selected group of people. For example, WhatsApp, Chaton, GTalk. So But I think that this instant messages is with a selected group of people. That even on Twitter and all that, I think you can only chat with the person you are following. So there are some kind of protocols. You see some kind of protocols that are in place, and we don't know. Some of us, we don't know that those things are called internet protocols. If somebody is not following me, it might not be easy for me to respond to the person's message like that. So that's why you see something like Twitter telling you that you follow the person. And if you follow the person will be able to see your message. These are protocols, because there are protocols that are in place. And I told you the other time that we are in multiple protocol environment now, multiple protocol environment. So there are protocol in place. When you see somebody, okay, you have to receive the person as if on Facebook. So you have to accept the person as a friend. Let the person be your friend on Facebook. So it's simply telling you that there are protocols in place that if you're not connected to the person, you can't send the message. Or the person you can't see the person's chat, you can't see everything. So because there are protocol, the internet is a multi-protocol environment, underlying protocols are there that you are not seeing. But the designers of the website, whichever website you are using, whether it's social media site or an official site and all that, they have also followed some protocols when they were developing the website. They have put some of those things in place. So that's why you have to follow people in your Instagram or Twitter to be able to access and pass information and get back information from them. So that's that about that. We have social networking sites like Facebook, Twitter. So social networking sites or SNS are used to build online communication to share ideas, activities, events, exchange files and pictures. So let's talk about the examples. And these sites are used by people almost every day for chatting, playing games, staying connected with each other, and all that. So we also have video conferencing, and is a live communication between two or more people at different locations. So example is what I'm using to teach you now. Zoom is a video conferencing platform, although our videos are off. So it's alternate to face-to-face meetings and usually involves audio, video, and data. So we'll see some of the required devices for video conferencing. Webcams, microphone speakers, visual displays, user interface control, and all that. So another service the internet provides is news groups. A news group is an online discussion group that allows people to interact on a particular topic. Unlike an email message, a news group message can be posted by anyone. So a user can start a discussion, post messages, and respond to posting by others. For example, if a news group provides services to exchange information about current affairs, it will have all the required documents. Like now, apart from Skype, WhatsApp, and other, we have different other softwares, applications that we created that serves like a news group. They all serve as a news group. They have different kind of them on the internet. So for the assignment, you are going to look at different applications that are created that are example of news groups. So you should note that and look for that, because it might be asking you some things. Some of them that they are basically designed for as the news groups. So the last service we are going to talk about is e-commerce that the internet provides. E-commerce or electronic commerce is a very important service provided by internet for financial transactions. Different type of goods can be purchased on the e-commerce site. online banking, trading of stocks, bonds, ticket booking, etc. also come under e-commerce. The mode of payment for such transaction is credit card. I'm sure most of us are doing this already on Konga, on Jumia, on Amazon, eBay, and all that, so on and so forth. They are all e-commerce sites. So this brings us to the end of this class. I said the other time that anything I have not mentioned on this, and you see on your chapter 9 of your textbook, please look at it. I'm sure there are just few things that I have not mentioned. Look at them and then note them. There are few things like the intranet software and the extranet software. Look at what's an intranet and what's an extranet. And I think the other things are just web browsers. What's a website and all that. So if we are done for this FS 113, if you have not submitted your manual, do so. And you have practice questions at the back of the textbook. So also please look at them. And because the exam is going to be purely objective. So look at them and revise your notes while you get ready for the exams. So thank you for coming. For those that missed this lecture, we're going to, this message is being recorded. So we're going to, we would share the slide, we share the recording to those that need them. Thank you for coming. Have a nice day. Before we go, do we have any question? If you have any question, you can just type them to the chat. Type your questions on the chat. Type your questions on the chat. And I'm expecting questions. So we are sending the recording. What we're going to give you is recording, not slides. I'll give you the recording. I won't give you the slide. So we are sending the recording. What I'm going to give you is recording, not slides. I'll give you the recording. I won't give you the slide. Any other question before I end the lecture? Any other question before I end the lecture? All right, thank you. Have a nice day.